استغنى إن إلى ربك الرجعى أرأيت الذي ينهى عبدا إذا صلى أرأيت إن كان على الهدى أو أمر بالتقوى أرأيت إن كذب وتولى ألم يعلم بأن الله يرى كلا لئن لم ينته لنسفعا بالناصية ناصية كاذبة خاطئة فليدع نادية سندع الزبانية كلا لا تطعه واسجد واقترب صدق الله العلي العظيم. Read, O Prophet, in the name of your Lord who created humans for a clinging cloth. Read, and your Lord is the most generous, who taught by the pen, taught humanity what they have knew not. Most certainly, one exceed all bounds. Once they think they are self-sufficient, but surely to your Lord is the return of all. Have you seen the man who prevents a servant of earth from praying? What if this servant is rightly guided or encourages righteousness? What if that man persists in denial and turns away? Does he not know that Allah sees all? But no, if he does not desist, we will certainly drag him by the forelock, a lying, sinful forelock. So let him call his associates. We will call the warden of hell. Again, no. Never obey him, O Prophet. Rather, continue to prostrate and draw near to Allah. Sadaqallahu Azim. Jazakallah khair.
Yeah. Jazakallah for the beautiful recitation. May Allah reward your efforts, Ameen. So, moving forward, uh, now to give you all who are joining us for the first time an idea about Professional Solidarity Forum, that is PSF, what it is, what it does, and what vision it has. I would like to call upon Ariba Sayed. She works as an economic and financial analyst. She is a core member of PSF and also leads associate of a core social service chapter of PSF. She shall also inform us on how you can be a part of PSF team, inshallah. The mic is yours, Ariba.
Assalamu alaikum, everyone. You can hear me, Zubia?
Welcome, Islam. Yes, you are audible.
I'll quickly share my screen.
Yes.
First of all, before we begin with our session today, let's get a brief about what Professional Solidarity Forum does. And it has been doing all along these years from 2017. So we were established as a registered organization from 2017. And we've been growing since then. We are people from IT and non-IT domains both as well. We are the platform where we are collaborating together to give back to the society for creative developments and skills, time, and to bring about a positive change in the society. So it's not just an organization, but a movement of hearts, hopes, and humanity. So Professional Solidarity Forum is a community built not just by professionals, but by the people who care. So people who believe that education is a right, not a privilege, that dignity begins with opportunity. Our aim and objective have always been self-development and community service. We are here for the people and by the people. We are this is the organized structure that we are built on. So this is the hierarchy where we follow the basic hierarchical distribution amongst us. So there's city president, there's city vice president, core teams, members, and associates. There's a monthly contribution by all just to bring accountability and responsibility amongst ourselves. So the city president, after all the main objectives of the organization, deals how to delegate them with the execution team that we have in place. And the monthly contribution for them is 500 and above, which whatever is convenient for them. Then come core teams. These are the leadership teams that are leading the three verticals that we have, which we will introduce in some time. So these are the teams that will work in coordination with city vice presidents and president to help deliver the activities that we do throughout the year. Then we have members who have a contribution 300 rupees monthly, which is again how actively they are participating in the activity, the PSF. Then our associates who have a voluntary contribution and they are passive members of our community. So they basically are hand for the members in the core teams. We have three of work, and we to fulfill our objective, the work and engagement focuses on three broad areas that we have. First is comes the service to professionals. Second is network and community building. Third is
Hi, hello, Ariva.
stars that you
You're not
guys.
audible actually. Can you please repeat the last section that you said?
Okay, am I audible now?
Yes, yes, you're audible.
I'm sorry. Maybe there's a network issue. Okay, so the areas of work that we work are three verticals. So to our objective, the work and the engagement focuses on three broad areas: service to professionals, network and community building, core social services. So to bring about a discussion and a brief introduction to all three, begin with service to professionals. So one so service to professionals, you are attending a masterclass. You're a part of an activity by service to professionals, all of you here. So master classes are a monthly engagements that we offer. This is an hour session on myriad topics that we are held. One of them today is as related to IT. We hold discussions about finance. We also hold discussions about mental health of people, the well-being people, career counselings, and various other topics that we have throughout the year that we are holding these sessions. This is a monthly. These are the monthly sessions that we hold for all of our people over here. There are online courses. We are enrolling people for online courses at almost negligible fees that you can contribute to and then avail these online courses. So these are 2-3 short programs for 2-3 months, and it just helps you develop your vocational skills and to be apt and fit for the society as a professional. So you can upgrade yourself with these online courses, mentor-mentee programs as well, where you can be a mentor as well as be an associate. It's just like how we have in our corporates. So this is just to support you, to give you an overview that how world is, and if you need a certain kind of help, there's a mentor to help you. You can ask him, you can go to him for career counseling, for your personal relations, for anything that you think that can help you with a discussion, cannot discuss with any other person over there in the society. You can join this program, take advantage of it, and develop your skills. We have course tie-ups as well. So basically we provide this again on negligible fees that we have. You can these are professional courses that we offer. Basically anything related to AI, maybe finance, again, psychology, anything that helps you build your vocational skills into the world fit. If we offer those. Second comes down to our networking and community building. So we are a community building program as well. So we try and create the habit of meeting people. We try and inculcate of engage with others. So something which brings about a change and happy positive vibe amongst all the members of our PSF. Uh, Engagement community, we hold psychological well-being and leadership, all kinds of sessions for our team members over here. We just sit along and talk about various other topics that are there, just not really, it's not about what is going on the world level. It is also personal. So we have get-togethers, we have half yearly meetups, as you can see. So we all gather up, have a lunch, have a dinner maybe, and just discuss randomly what we are talking about, what we are facing in our lives, how is work life, how is home. Dinner meets again is something which we yearly or quarterlies, whatever is convenient for all the members over here. So there's it's just an informal meeting discussing how we've been all along. No discussion about what we are doing as PS, no discussion about what we are doing as individuals in life. It's just random discussions to have fun with each other. Again, family connects are something we're about our families, our spouses, our children, our mothers and parents, our, our, sibli- our siblings together to get to know each other, build a community for ourselves, and basically have a well and supportive community towards each other. Here comes our flagship programs, which are under the core social service. So these are the two flagship programs that are basically the core of our PSF. This is Kafalat and Neki Basket. Beginning with Kafalat is a child education sponsor program. It's completely transparent program where a donor meets a potential student. Donor gets the details of this potential student through our website. He or he can directly support the student and sponsor him or her whatever amount he's fit suitable for. So for the academic year 2024-25, we were able to help 272 students in total with a total amount distribution of nearly 27 lakhs. And we are geographically approachable in the areas of Mumbai and suburban areas. We have been successfully delivering sessions to these children and their parents, meeting with them, bringing sense of responsibility towards the donor, towards their education. We've been nurturing them. We've been trying to help them through all sorts of possible means that we can arrange for them. So the donor has to be really free-minded when they come along to the website, that is www.educatechild.in. You can visit us, select your student you want to sponsor, and then you can directly go ahead with that particular student, bring about a change in his or her life. This is a normal stats that we bring about. So you can have a look over this. This is year-on-year growth for Kafalat. We've been targeting 50 lakh rupees this year, 2000 for the year academic 2026. We want to support 400 students, and we have a targeted reach of 15 lakhs teachers as well. So we are hoping that we will be able to reach this target this year, as much as possible optimization of our resource organization. So this is the cycle that we follow for Kafala. So you can basically, as I said earlier, you can browse the listed students and causes. You can select which student that you want to donate for. You can donate online and get your donation reaches the student. He or she you will get your receipt and the student gets their fees. So it's a very transparent system. As I said earlier, you directly go and select your student, and he or she will be able to get your through you through your donation with through directly through our website. Next comes our Neki basket. This is something which is based on the idea or the concept which was first established in Turkey. So it is ki tokri, which was called in Turkey. So this is a concept based on that. We provide a kitchen available on various Mumbai suburbs and provide these meals to the needy. This is the vision and mission to elevate the hunger and malnutrition among urban poor families by providing nutritious meals and fostering self-sufficiency with a vision to expand our impact of cities by 2030. So, our aim is to establish 50 kitchens across 5 cities by 2030 and providing daily meals to around 1,000 needy families. We are located in Jogeshwari East, Ambujwari, and Malad. We are benefiting around 170 plus families this year. The service has been provided for more than 3 years now, and 10 meals per month are served per location. More than 30,000 of total packets have been distributed since inception. So you can again a separate website that we have for Neki Basket. You can go ahead, donate for Neki Basket. Again, this is just a poverty elevation program that is conducted by PSF to help people not starving in the tough months of their life. And it is just creates meaningful anything which is gives nourishment to the families. We just don't give meals, we deliver relief, passion, and a reminder that they matter. So it's basically something which is providing them with a source of belonging to the society. Again, this is the cycle that we have for Neki Basket. Programs are, as I said, that we are a registered organization. So all seats that you are getting, you are eligible to apply for tax returns. It is comes under ATG section of income tax. So you can easily avail those benefits by the government. So last but not the least, what makes PSF special is that it's not the scale or the structure or the sincerity. It's the people who give consistently because they believe in a better world. So when we talk PSF, we're not just talking about the programs and numbers, we're talking about a legacy here. We're talking about humanity in action. And today I invite you not to just join us, belong, because with PSF, you're not a donor or volunteer or name and list, partner and purpose, a builder for futures, a reason for someone's smile. So I urge you all to ponder upon what PSF actually is and how we about to just learn, come join us, have a visit when you can, and see what we are doing. And if you feel like you can come and join us. Thank you for today, and let's begin with the session now. Over to you, Zubia.
Yeah. Jazakallah khair, Ariba, for the introduction. If anyone has any queries regarding PSF, you can reach out to the admin of the WhatsApp group. Yeah. So let's moving forward. I welcome you all to this exciting masterclass on exploring the world of data science and generative AI. We are living in a time where data is shaping decisions, driving innovations, and transforming the way we live and work. From predicting trends to generating human-like content, the power of data science and generative AI is truly redefining possibilities across industries. Whether you are just starting your journey or looking forward to deepen your understanding, this session will give us the valuable insights into these technologies and why and they matter more than ever. Thank you for joining us. Let's dive in and explore the future together. Before we start our session, it's my pleasure to introduce our speaker for today's session, Samreen Khan. She is senior data scientist at Fractal Analytics with 10 plus year experience in AI ML. She has specialized in computer vision, deep learning, and generative AI. She is skilled in end-to-end model development and translating AI into business impact. An honor to have you with us today. For the participants, you can drop your comments, question in the chat box, or raise your hand and engage as much as you can to make this session interactive and fruitful for you and others. Your question will be addressed now or at the end, whichever will be suitable for the speaker. Now, over to you, Ms. Samreen Khan.
Jazakallah khair, Subia. So, as she already mentioned my introduction, so my name is Samreen Khan, and I think that she already mentioned. So let's directly jump to the session. Am I audible properly?
Yes, you are audible clearly.
Okay. So let me share my screen first. Is it visible?
Yes, it's visible.
Okay. So let's directly jump into the session. So today the topic, as mentioned, is like data science and generative AI. We all know nowadays there is so much hype and so much excitement in the world of data science and the generative AI. So we'll first start with the data science and then we'll eventually jump to the generative AI stuff. So what is data science? Data science actually is the art of it is an art and science of turning data into decisions. So nowadays, because of social media and because of like everywhere there is a data, so people started doing some stuffs on data, and then they came up with something which is called data science. I think from 10 years from like before, there were no much progress in the field of data science, and people were even not knowing about it. But from last 10 years, data science has progressed a lot, and it has benefited uh, people, company across many industries. I think now almost all the industries, all the companies, they need data science and data scientists. So what is data science actually? So where we have data, as I mentioned, but can we leverage the data to come to some decisions? And there comes data science into play. It helps us getting decisions from data. Like it is like a detective, so which tries to find clues from data. And then, like for example, you can imagine there's a magnifying glass, and the that detective is going through data and trying to get some insights, some uh, information, something which can benefit their specific domain. To make it understand better, I would like to give one of the analogy, as analogy makes things better to understand. When it comes to cooking, it is very much similar to that. Like if we want to understand it, for cooking, what we need first, we need ingredients, right? Then we need to know the recipe, how to make that recipe, like a dish. So there is a proper procedure, and that's called recipe, right? And after that, there's a chef who is required, and in our home we are chefs. And finally we make dish. So in the same way, for the data science, the ingredient is raw data. And then after that, we require a CPU, which is nothing but algorithm and models. And then data scientist is a chef here, which uses raw data, algorithm, and models to come to the final dish, which is the decision, predictions, and insights from data. So this is something which is to understand how the data science works in the layman terms. Uh, I hope it is. I hope I'm able to explain it at any moment of time. If there's any question, you people can ask definitely. Then I'll give some examples here. For example, like when we all see YouTube videos, but have you ever wondered, like whenever we see any like 2 3 videos, we get similar recommendation, and somehow we feel like how they know that we are interested in such type of videos. So the magic behind is they are collecting our watch history, which is called data collection. And then what happens in the behind scene is the algorithm, the model that is there, it does data analysis, which is trying to find pattern, what kind of stuffs the person interested in, what they frequently see, and what is it based on some current season. And there are many features, and there are many things to get to that decision. And then finally the recommendation system recommends the videos to us, right? And that's called prediction, and it comes under predictive modeling, suggesting videos. So that is one example. Then there are other examples also that I would like to give. For example, spam email detection. Earlier, like many years back, we used to get lots of spam email, right? But nowadays, the spam email that we get is like they are properly filtered into the spam folder, right? We don't get that in our primary email inbox. So the model which is deployed, which is working behind the scenes, like it's a what it does is it classifies the email into spam email and non-spam email. And how does it does? So again, we have lots of data, right? And when we have lots of data, uh, we uh, we or the data scientists or the one who worked on it, they know that okay, these kind of email are clean, non-spam, and these kind of emails are spam. Then what makes those emails spam? Maybe it contains certain links, certain vulgar language, or some suspicious things. So then the classification is done. Those emails which comes under spam category, they are marked as spam, and other are clean. And then model is trained based on this data. And once the model is trained properly, it is able to classify the new email either into spam or non-spam, right? Then this is how this spam email detection works. Similarly, there is a Uber system. Like, have you ever wondered how the Uber or Ola, whatever it is, they give us price recommendation, or it's not recommendation, but it is never fixed. It keeps on varying based on time, seasons, right? How does it does? How it gives us uh, like live or dynamic pricing. So there is a algorithm, there is a model behind which is working. They what they have in terms of data, they have traffic data, they have user related data, they have seasonal data, right? So there are different kind of data actually. And uh, also there is so because from this they infer demand and supply, right? At what time, at what season demand is more and the supply is less, or when the vice versa. So all the historical data, live data, which is traffic data, together when these data works, then there's a model which leverages this, which is machine learning AI, and they adjust fare in real time, right? So this is how they do automated decision making. So it's not something like some kind of magic, but it's data and the predictions, and that's how it's give us smart pricing decisions. So that's how you can see it doesn't depend upon the domain. In every domain now, this thing is being used nowadays, and it's very useful. So let's understand some of the stuff which comes under data science, what it is, and what skills we need, what are the tools. So in today's session, we'll try to see, or we'll try to go uh, over in a brief. We won't dig much in details because then it will require lots of session to get into the details of everything, but we will go through overview of everything, so that anyone who will be interested in this field, they know where to start and in which direction to go. So data science, what it requires, it is an intersection of maths, and statistics, along with programming and domain knowledge. These three things are very important. So, first thing that it demands is that people should be good in statistics mainly, because maths has also lots of things, but mainly one good in statistics definitely can crack this. And once you know you're good with that, you should be knowing the programming, because at the end of the day you need to do the coding and the programming, right? To get to this modeling part. And after that, domain knowledge is equally important. It's very important actually. Without domain knowledge, just statistics and programming won't help. For example, we are creating something for the medical domain, and we are trying to predict some new drugs, or we are trying to classify a disease based on symptoms, based on X-ray reports and all. But if we don't have enough knowledge, or at least the required knowledge of that domain, like what is X-ray, for example, if it is medical domain, and what kind of disease there, and if those knowledge are missing, and suppose if it's a finance domain, we don't have any idea of finance and how it works, then how will we be able to go through the data science modeling thing? It is not. It is not possible. So domain knowledge is something which is like anyone can acquire based on which project he is working, he or she working. But the core of it again lies in your programming skills, your mathematics skills, right? So that then we go to the specific skills that we would master data science is uh, what you can see here. So there are technical skills like as I mentioned, when it comes to programming language, Python is a go-to language. It's a like large portion of people from this community use Python only to get to the data science stuff. Then there is a SQL, which is data management, which is for basically data management, and the pandas, numpy, all this I will go through this, but these comes under Python only. We need to be good in visualization, because when we have data, we can't see data, but when we visualize using the plots, diagrams, then it makes much sense. One should be good in creating visualization and explain it. And of course machine learning, we'll go through this in the coming slides. We should be good in modeling machine learning algorithms and so on. And apart from the technical skills, other skills that is very much needed is soft skills that one should have, like good communication. Storytelling with data is something very important. Data tells some story, right? It has its own story, but we should know how to tell story using data. And of course business understanding is a must. If you don't understand the business, how will why will you even start doing things? So once people understand business, then they can start with what's like this is the problem, and then this is how we can solve it, this is how it will benefit, here is the problem, here is the solution for a particular industry. So business understanding is very important here. Coming to the tools, of course, as I mentioned, programming, Python, there is one language called R that is also used. Then for data wrangling, we have the packages like Pandas and NumPy. Visualization, as I mentioned, databases which are SQL, MongoDB. And there are ML and AI algorithms, which one can always see, Google, and find out. And for collaboration, there's a of course there's a Git, Jupyter Notebook. I think we all are aware if we are in this field. Then okay, this is a little heavy slide, but it will help us understand the entire life cycle for the data science. So I'll walk through you people through through the steps of the data science life cycle. And I'll try to first I'll give explanation of each steps. Then to make it understand better, we'll we'll go through the analogy, because that makes things much clearer. And after that, we'll see some real life examples, so things will become inshallah much clearer after that. So first step in the data science lifecycle is problem understanding, because as I mentioned earlier, if we don't understand the problem, how come to the solution, right? So problem understanding, like is very much important. So what is problem understanding? You need to understand, or you need to define the goal, what we want to achieve. What is the question, what question we are trying to answer. So once that is clear, then we can move further. So now the problem statement is clear, our goal is clear, what we want to achieve, that's clear in our mind. Then accordingly we'll start working. Then what we'll do in the data science, if we are developing some data science application, The next step is collection of data, right? So whatever data, relevant data according to our problem we are getting or we are able to get, we need to collect that. So mostly data collection steps involves collecting raw data, because you will never get the ready-made data which is ready to use for your modeling part. So whatever data, even if it's raw, just collect it. Then comes data cleaning. Now, as I mentioned, data is not clean and it's not ready-made. So when you are when you are not solving any real life problem, you are maybe you are participating some in some competition or something of the same sort. In those cases, you may get some clean data to directly work with. But for the real life projects, for real life application, we never get the clean data. So data cleaning step is very important. So what it does, like for example, if there are some missing values, there may be incorrect data. You need to filter that out. You need to, as I mentioned, if there is missing values, you need to fill that, and then how to fill those missing values, that requires again lots of strategies. So we need to master those things. And once we have data, now we need to see how data looks like. So there comes the data visualization part. In the data visualization, we use graph, charts, basically to understand the trends, patterns visually, because image speaks thousands words, right? Otherwise, data is, they are in crores, but then in one graph we can see lots of information. In one chart, we can visualize lots of things and insights. So that helps a lot for the further steps in the cycle. So once we have data, it is clean, we also visualized it. Now there comes feature engineering part. So feature engineering is like extracting features from data, or sometimes uh, creating new feature from the existing data. So feature is something which actually is fed to the models, because directly data cannot be fed. We need to create some features out of it, and once we create those features, that is fed to the model. So some features are some data is some there are kind of data which are featured directly, and we don't need to do much, but sometimes we need to do some tweaking, some wrapping around the data to make it as a feature. And from feature, there's one more step which is called exploratory data analysis, EDA, where we try to find more insights and patterns from data. Again, so it's part of extracting features from data, exploring the same. Now we have data features. Now comes the model building part, which is the heart of the data science lifecycle. Here comes machine learning models into picture, which uses data to make predictions and decisions. So we so till now we prepared data, we prepared features. Now we fed these data features to machine learning model, which is trained on this data, and once the model is ready, it is able to predict and give us decisions. Right now, when that uh, steps comes, like how training takes time. Actually, it's not like 1 or 2 minutes things. Sometimes training takes days, but because of the hardware advance and GPU advances, now the training time has been reduced. But again, it takes at least few hours. When we have large data and we are developing some good models, it takes few hours to train. So when we have model which is already trained, how to evaluate it? Like for example, now we have a model, but whether it's working properly or not, we cannot directly deploy it somewhere and use it. No, we need to evaluate it. So there comes model evaluation, which basically checks how well the model is performing, how accurate it is. Once we are satisfied with the accuracy of the model, now there is a time to deploy it. Deployment is something which is a state where one can use the model. Hmm? So put the model in action. so others can use its prediction. This is called deployment. And deployment itself requires lots of engineering stuff, MLOps and other stuff. So that's a deeper thing, but anyone who's interested in deployment of machine learning models can go through that and see what are the different uh, tools and strategies and stuff that one needs to learn to deploy the machine learning model or AI model. And it's not like once we have we have deployed a model and it's done. The models continuously require checking and improvement, because at the end of the day it gives us results based on data, and data is something which is never constant. It keeps on changing, it keeps on increasing. So if we don't update our model with the latest data, with the updated data, then our model won't be useful anymore. So monitoring and feedback is continuously required. So these are the cycles and the steps involved in the data science uh, applications development. These were the explanation, basic explanation. But let's go through the analogy to make it better understand. So again, we'll see our cooking thing, the dish making process. So like problem understanding is like we first need to decide, right, what dish we need to cook. Then again we need to collect data. So like for the case of cooking, just collect the ingredients. Then cleaning, of course, for example, we are making something which requires vegetables, so we need to clean those vegetables, right? We need to wash it, we need to clean it, cut it. So that the cleaning part, washing of the vegetables and all, that comes under data cleaning. And the data visualization, like as you can see, like, oh, we need to see, we need to label the ingredients. Okay, this is this, this is this. So labeling of the ingredients is a visualization. Then feature engineering, you can say that, like, we are just enhancing the ingredients with spices, or we are cutting the, because we, for example, we have some vegetable, we cannot directly use it, we need to cut it in some shapes based on what vegetable we are making. It's not like we are directly taking the vegetable and putting into the kadai, no, right? We need to give give it some shape, we need to make it small, and all those things. So that's called feature engineering here. And EDA part is like, you are tasting the ingredients before cooking. And once all the pre requirement is done, like for example, collecting the vegetables, washing it, cleaning it, cutting it, tasting it, labeling it, now it's time to actually create the dish or cook the dish. So cooking the dish using the recipe is what the model will impact. And of course, whenever we cook the food, it's never like we are just putting salt and spices without testing. We keep on testing at every steps. Okay, whether the salt is not increased and so on. So the testing is done. We do that. We taste it, right? Why? Because we want to evaluate whether, so if something is everything is right or not. If whether it require more of this ingredient or that, right? So that evaluation part is here. And then of course deployment is nothing but serving the dish to the people so that they can eat. And again, when we as a chef, we, or for some guest, we make something or some event, it's not just we just serve them and we go. We ask them, no, how it was made, like what was the taste, whether it was good or not. So what I'm going to say is that we try to get the feedback. And based on that we adjust, no. If we get some negative comments, we take that and we take note down notes of that, and next time we try to not to do that same thing, or we try to improve based on the feedback. So that feedback thing and the monitoring part is important. So this is how uh, so it's very much similar to, so we data science also goes through the similar steps. It's not like one step process. Like many people, the newbie, mostly they think that it's only creating models. You just train ML algorithm, ML models. You just train a model and just put that into predictions and done. No, so ML, the model building is only one step of the entire process. There are many pre-processing and post-processing. Not we cannot even say that as pre or post-processing. They all are steps, and together they, um, when combined, give us the final application. So let's quickly jump into some real life examples, how it is actually done. So, for example, a shop wants to know which products will sell more next month. So, as I mentioned, data science is all about predictions, making decisions based on the data that we have or one have. So, there is a shop, and they have data, like they have data of selling of their products. Based on that, they want to know which product will sell more next month. So of course now they have data, but the data is spread everywhere randomly. So first step is to collect data, like collect sales record, customer visits, holidays, weather data, right? So sales record, like which product, when it was sold and all those things, which type of customer comes, which type of customer buys which types of product, when are the holidays, because certain products are sell more on certain times in the year. Holiday seasons is different. Some are seasonal data, like we buy sweaters, of course, in the winter season, for example, and the umbrella in the rainy season. So these are data, no? But if we don't make any decision from this, no one buys, raincoat in the summer season, and if someone starts selling uh, umbrella in the rainy in the summer season, it won't benefit them. So, but this was very easy to make decision as a human. But then when we have huge data, human mind cannot make decision based on that huge data. Then this data science thing comes into play. So that person, the shopkeeper, what he does, it collects all data that he has, relevant to the products, or the shop that he has. Now, as I mentioned, the data might not be clean. So there may be some duplicate entries, there's some spelling mistakes, some missing values. Then just correct that, rectify that. Okay. And once the data is clean, then just visualize through the graphs, charts, like which products sell more to, in which season, what was the price trend, all those information, and the timeline chart, they are also important. Feature engineering, like as I mentioned, I'll give example how to create features. For example, like we have dates, like on this date this was sold, but then we need to create suppose we only need month or we only need week of the day, so we can create those new feature from the dates. Or sometimes we create new feature from the existing. For example, we have temperature data and humidity, we combine them and we create new feature. So that was just one example, to create new feature which comes under feature engineering. So now we create all those features, and then uh, EDA comes. So here they discover that more snacks sell on rainy days or during festivals. So as it is exploratory analysis, so the data analyst, they does this part, like which type of, if it's a snack related shop, then they discover whether, as I mentioned, seasonal things. Okay. Like whether which snacks sell more on rainy days, or if it's based on festivities, then just check that. So these comes under EDA. Now all this data is now ready with the shopkeeper, one who is doing this. Now comes the modeling part. So model is trained and it predicts the next month's sale based on all these data and trend. And once a model is trained, the prediction is done. And initially we have, how the evaluation is done. Evaluation can only be done when we have true data, or like true predictions. No, it's not prediction, uh, ground truth it is called in this domain. So when we already know the ground truth and then model predicted something, then we can cross verify, right, whether the model predicted right or not. So normally the first phase of evaluation is we need to have the ground truth with us, and then model will predict something and we'll compare the two. If they are same, then of course the model is good. If they are diverging or different, then our model predicted wrong. So in order to know whether our model predicted wrong values, we need to have ground truth with us, right? So that's how evaluation done. So that was the basic of evaluation. That itself is a very deep study. There are many evaluation methods and on and so on. You can check that. So when everything is ready, modeling is done, evaluation is perfect. Now just to deploy that model. So show predicted sales in some kind of dashboard, you know, or alert system for the shopkeepers. So create some sort of UI where the this train model is working at background, right? So that's a deployment part. Of course, in most of the cases it requires some fancy UI, some alerting system, right? That helps the owner of the shopkeeper in this case. And now the last part, update the model, like as season changes, as customer behavior changes, because no customer is always constant. Their behavior changes, their habit changes, season changes. So keep on monitoring the model and update it based on the feedback. So that's how it works. Let me know if it was clear or if there is any doubt. I'm happy to answer the questions. Else I'll just move to the next slide. So we went through the life cycle of the data science. Now, how to do this? How to start? So we need to know, as I mentioned, programming. And when it comes to programming, Python is go-to language for this. So Python for data science. Why? Why it is mostly used? First of all, it is very simple and readable, right? And anyone can learn it. So it has a it is very easy. At the same time, it goes to very high level also, and along with it, it has very huge community support system is very good. And when you have some doubts, so there are lots of help online and lots of tutorial available, to solve any problem or issue that we might face. And it has lots of libraries which helps in the various steps of the data science life cycle, as we saw. So that requires lots of tools and libraries that is already inbuilt in the Python programming language, that makes things very easy and adaptable. And other thing that is very good when it comes to Python is it's free and it's open source, no cost involved, and it can be used in industry without any cost, and also for the academic purposes. So where Python is used, from data collection to cleaning to visualizing to modeling to prediction, everywhere. And for everything there are different. So if you don't know the Python, just understand that there it contains packages, and each packages has its own purpose. For example, is a package in the Python called pandas. It is used for handling data. Then there are other packages which are used for visualization, like matplotlib, seaborn, and there are many others. And then there are packages for machine learning models. One of them is scikit-learn, and there are many others. I just give examples to understand that these are the name of the packages. So there are various packages, and we can explore them anytime. Then let's come to the machine learning part. What is machine learning? Uh, Machine learning is a way to make computers learn from data and make decisions or predictions without being explicitly programmed. So before the machine learning thing, data science thing, we need to do coding. We used to write program, we used to write logic, and then get to the decisions. Not decision, but yeah, based on the logic that we wrote by our own, the program, it goes through that and gives us some results. But then here we are not doing explicit programming. We are just feeding machine learning models data, and we are cleaning, of course, data, preparing data, cleaning data, getting feature out of it, But then using that decision prediction, how it should be made, we are not writing any logic or any rules. That rules and the logic that is automatically created by machine learning model, and that's the magic of it. Hmm? So, for example, um, when we are training a child, so instead of giving exact rules, you show them enough example to let them figure it out. For example, there is a apple and mango. For the first time, the child has seen the apple and mango. So the traditional way of explaining the child is that this is apple. Tell them, okay, it is a red color. It is of this shape. Okay, it the structure looks like this, and so on. Give them rule so that they just understand. Okay, whenever it is reddish, whenever it is of this shape, then it is apple. But then this is one way. But then the machine learning way is show them enough apples, okay, and then tell them this is apple, and then show them enough mangoes and tell them it is mango. So next time when you give them new apple, they will automatically understand that okay, this is apple and this is mango. Why? You didn't tell them anything like this mango is yellow, this is red, or this is this of this shape, this. So these were the logics or rules. You didn't tell him, you only showed them data with the label. So when you are giving them apples and telling them it is apple, that apple is a label, right? So giving data along with the label makes child understand automatically, and this is how this power we leverage in the machine learning, right? Very simple intuition. When people worked on it and they cracked it. So traditional programming, you write rules, computer follows them. Machine learning, you give them enough data, examples, labels, and then the computer automatically learns the rules. So some examples, like as I mentioned, email spam filters, and there's a Google map which predicts fastest route using past data. There's online shopping. Whenever we buy something or we serve something, we get recommendation of product based on our behavior, and we are like, oh, we wanted this. How does it come? So there's a model working behind in the bank. So if we look at the bank domain, finance domain, detect fraud from transaction patterns. So whenever there was some fraud, they try to find the pattern in that transaction, and then they mark it as fraud. The same way the spam filtering thing worked. And in case of hospitals, predict diseases from reports and symptoms. So whenever we have data and label, we can train our ML model and get to the results. So, okay, so here there are three types of machine learning. So I just came with the labeling part, as you would have heard. Like we have data, we have label. So actually, there are three type of machine learning: supervised, unsupervised, and reinforcement. So when I said that we have label, that basically comes under supervised machine learning. So what is supervised machine learning is like you have data and you have label. Like as I mentioned, there were lots of apple, and I told child that it is apple, so or mango. So that is label. Yeah. So whenever you fed data along with its label and train a model, it is called supervised learning. And sometimes we don't have label, like we have lots of data but we don't have label, we don't know what it's called. Then in that case, unsupervised learning comes into play. What it does, it automatically groups data based on some pattern, some behavior, something. Like for example, if we have lots of customer data, we don't know how to label customers. So we have behaviors as one of the data of the customer. So we can group a customer based on behavior as one of the data. So like if some customer likes for example, they like cake, there are set of customers who like cake more, then we group them into one. If there are certain uh, customer which likes cold drink more, then we create another group. So this is actually called clustering in this domain. So that comes under unsupervised learning. When we don't have label, it doesn't mean that we cannot do anything with the data. Then also lots of things can be done, and we can again infer lots of insights from the data even if there is no label attached to it. And there is an advanced level of machine learning which is called reinforcement learning, which is normally used in cases of robots and all, where uh, we try to teach machine by doing trials, and when it makes error, feedback is given, it against tries, then it against gives us error, then so all those things. So it is very it is little bit of advanced thing, but just to get you familiar with the term reinforcement learning, uh, one who is interested in robotics and all, uh, in the AI domain can definitely look into reinforcement learning. Then there are certain key terms in ML I just go through, because whoever dives in this domain, they will keep on hearing these terms like model, features, label, training, prediction, accuracy. I think we already went through some of it. So model we all know, which is nothing but brain. We train using data is a model. Then features, input data used to make prediction. Then there is a label, as I mentioned, that we associate with the data. And then training, which is where we fed data to the model and that model is trained. And finally, when it gives us output, the model, when it gives a output, that's called prediction. So what the model thinks the output will be is a prediction. It may not be right, it's what model thinks, but the better the model, better it is, closer or equal to the ground truth. And then accuracy is often used where we check how well the model is performing. And then let's come to the different kind of algorithms that are there under ML, machine learning. So there's a classification, there's a regression, there's clustering in advanced. Classification is very simple, just take that same example, apple and mango. So it's a binary classification. So we only fed two kind of data to the model, the apple and the mango. So it's when we give the new apple or mango, it either classified it as mango or apple. That's called classification. Then there's a regression. Uh, I won't go into detail. You people can go through it because we don't have enough time and we need to cover some other thing. Then there's a clustering, as I mentioned. Grouping of things based on the certain features that we infer. And then there are advanced layer of algorithms which comes in the neural networks, XGBoost, and so on. So normally how ML workflow works is we have a data, we clean it, then we split that data into train and test. So it's very important because there's the evaluation process. As I mentioned that steps, if you remember the life cycle, we do evaluation. And for evaluation, we need to have ground truth. That's why we need to split our input data into train and test, because input data will always have ground truth associated with it, no, not the future data. So we take only, say for example, 80% of it to train and 20% of it to test. So how to split that data, that is also there are also lots of strategy for that also. So once you do that splitting of train test, then you need to create model and then evaluate and improve and use it, and that's it. And this is some a small snippet of the code, how the Python code looks like. So if you have some algorithm, just this is how it is, simple one line, and then you just fit the data like this. Before this, you need to train X, train Y, and you to create. So I just put one snippet of the code just to make it feel like how it looks, and then you just do this model dot predict, and then you get the prediction. So what next? What is next in your machine learning journey? If anyone is interested, what they can do next? Because here we only covered the shallow part of it. We just went through overview, not the deep study. So hands-on practice is very important. Go to the Google. Try to have beginner data set. There are lots of data set available freely. Like the simple one is Titanic and house pricing data. And of course, when you do ML or AI stuff, you need high power GPU. Most of the time, CPU is not CPU is something like we don't recommend because it is very slow. It requires a GPU at least. So, but the good news is that we can get the free GPUs online. You can use Google Colab, Kaggle. They provide GPU and TPU also. But yeah, GPU is enough for us to get start with these things. So search for the online data set, go to these uh, you know uh, Google Colab and Kaggle and start coding, and you will be able to use their GPUs for free. And learn Python if you're interested in this, that will help you. And learn model building and how to evaluate models. Do small mini projects, that will help a lot. As much as you learn by doing, reading doesn't help much. Keep on doing and then simultaneously keep on reading, that helps. So the best way is to participate in ML challenges. Kaggle is Kaggle, it hosts the data science challenges. You can go there. And there are other stuffs or platform available where the online uh, challenges or online AI related competitions are hosted, and you can take participate, because when we participate we engage, and that is a very good way to learn. And learn some visualization skills, because once anyone can master the visualization of the data, then it's like they hold a grip of the same, and then the further steps becomes quite easy, because we are able to understand data quickly. And the more we start understanding data quickly, the better model we can develop. Okay, so that was about ML. Now let's quickly go through the deep learning, which is the next step, or one more advanced level of the AI. As you can see, so we are what we are seeing here is AI. Everything is artificial intelligence. Then in under this there comes machine learning, and under machine learning there comes deep learning. So what is deep learning? It is a subset of machine learning that uses layers of neuron to learn from data. Neurons, as you are seeing here, it might not be new terms for us because we have heard neurons before. Our mind, our brain has lots of neurons. Crores of neurons we have in our mind, our human brain. So the idea was why it came, why deep learning came. So it was inspired by our brain functions, like the way the human brain process information, because our human brain is amazing, and the way we come to the decision is like scientists are exploring that. And can we have similar thing in the mathematics, or can we copy that, so that machine can also use that kind of functionality, uh, the like our brain uses, and then comes to the decision. And they eventually cracked it to some level and came up with the deep learning thing, right? The key feature of the deep learning is it can automatically learn features from raw data without manual use. So I'll tell you the difference. So in earlier programming, we used to write rules and logics. Then machine learning came. Here we define features. Actually, we are not writing rules to create a feature. We are just listen properly. We are not writing rules to create features for ML part, right? But we are defining feature. Okay, we need month, for example, month number. We are defining this as a feature. We need month number as a feature to for the machine learning model, right? And that's how we need many other features. We define it, but then after that, once we define that features, how to use that feature, that we don't care. That ML model will take care, right? But we need to define feature. That was part of ML. But in deep learning, the the main magic is we don't even need to define what features we need. It can automatically learn features from the raw data. You don't define, okay, we take this, or create this. No, just give it the raw data. It will learn feature. It will create feature, whatever it is. It will do on its own, and will start training. And so when it comes to images, speeches, languages, video, and large and complex data, now only deep learning is used. Only deep learning is used, because we cannot keep on defining features for such large data. That again is a very hectic job. So when it comes to image processing, NLP, natural language processing, video processing, deep learning is used. So this is simple diagram of how this it will be really advanced topic, but just to get to you people familiarized with this, I just mentioned this slide. You will have input, there will be input layers, there will be hidden layers and output layers, and then output and so on. Feel free to explore on your own because it is worth exploring. So as I mentioned, deep learning was traditional. So feature extraction was manual. Here it is automatic. ML requires less data. Deep learning, it does automatic feature extraction, but it requires more data. Okay. So when it comes to structured data, what I mean by structured data is tabular data. So when we have data in Excel, CSV files in a table format, then ML works quite well. But when we don't have structured data, like we have data in the like images, we have audios, we have videos. In that case, deep learning works best. ML doesn't work here much better. And here, some of the ML algorithm are decision trees, SVM, and the deep learning algorithms are neural networks, CNNs, RNNs. Just take note of these words, and you can explore them in details. Like CNN is not so here we'll see this like common deep learning architectures. We have NNN, like which is artificial neural network for structured data. When it comes to image processing, vision, computer vision, the type of architecture which comes under deep learning is CNN, which is called convolutional neural network. And when it comes to sequential data, text, and all, then these are RNN, recurrent neural network. And the most important is transformer, which came in recent years. Which transformer is a kind of architecture which again comes under deep learning, is what is the most powerful architecture today using GPT, BERT, and DALI. So Chat GPT, the revolution that we saw in past 1 2 years, is a magic of transformer. So it's worth studying how transformer works, and Chat GPT is based on that architecture. So when it comes to deep learning, these are the libraries that you need to start with. So learn tensor, either learn TensorFlow or PyTorch. Both does the same work, but TensorFlow was created by Google, and PyTorch is from Facebook. So I have normally used PyTorch. It's much simpler than TensorFlow. But then, if you want to use TensorFlow, these are libraries which help us develop deep learning application. Keras is nothing but the wrapper around the TensorFlow, which makes TensorFlow easy because it is a little bit complex but more customizable. If you are interested in image processing, OpenCV is something which can be used for pre-processing, uh, because image is something which requires pre-processing before you actually do the main real part. Then there is Hugging Face transformers. Here you will get lots of pre-trained models, not just NLP models, other models too. And there are some miles around deep learning that only uh, okay, only the PhDs, it's only for PhDs known. Anyone can understand, anyone can start, just start learning these PyTorch or Keras, Kera, which are beginner friendly libraries. It's not magic, it's data and computation.
Excuse me, Samreen. Sorry to interrupt. Hello.
Mm-hmm.
Yeah, we just have only 10 minutes left for the session. Just informing you so that you can go forward accordingly.
Yeah, so I'll just go through all slides quickly because I think we can't even jump deeper into any of the slide,
Yes.
but it's good to familiarize the terms with the people. So yeah,
Yeah,
I'll
yeah.
so yeah, as I mentioned, it requires GPUs and hardware, but then it doesn't mean that everyone needs to have access to supercomputers. So as I mentioned, there's a Google Colab which is for free. There's a Kaggle which also hosts free GPU, so you can use that and start with. And people think when we start using deep learning it will always give you perfect result. No, it's not like that. It sometimes overfits, sometimes fails, sometimes it becomes biased. So it's all about how well you train your model. And as I mentioned, it always required fine tuning. It's not like once train and you can use it for always. Not real model needs retraining, fine tuning over time as data changes, because this is a key. Data changes, so your model needs to update it. Then, okay, quickly, this is the last part actually, the Gen AI stuff. So, data science came into highlight in around 6 7 years back. People start this deep learning cracked. It's deep learning was there in 2016 onwards. Deep learning start cracking problems and start giving exceptional results. And so that people and companies start adapting deep learning based models and all. But in Gen AI, we all are seeing ChatGPT and all. It's from last 2 years. This Gen AI thing came into picture, and it also changes the industry, the community, and everything, and it helps people a lot. So, what is generative AI? So, generative AI is a type of AI that can create new content. So, it's not about classification. It's not about grouping. It's not about prediction. It's about creating new content. Okay, so nowadays we can create images, we can create new text, we can chat with the AI bots, right? We can create videos, music, and so on. So it's like supercharged creative assistant. It has read and watched everything online, so that based on that it can create something new. It won't be similar, like it will be similar actually, but it will not be copy pasted or something. It will be its own new content, original output. So we people, you can use Delhi and Mid Journey to create to see how you can create new images. I think WhatsApp also now provides that. You just give the prompt and it will generate image for you. There's ChatGPT, we all know. You ask anything, it will give you answer summary. There's a GitHub Copilot, the one who is in coding. For it help. It will save lots of time. It will write code for you. You just mention what you want to, and you just Copilot will write code for you. If you want to create videos, there is a tool called Runway Synthesia. You can also create AI generated music and soundtrack. Okay, so it's based on deep learning. This DNA tech, it learns the pattern from past data and generate new outputs. There is a application, vast application, like from marketing to movies, you know, marketing, education, healthcare, gaming, e-commerce, everywhere. Like this is used, so because it generates, so for marketing it generates banners, product images. For education it generates notes, the summarization, quiz creation. For healthcare it will give you synthetical medical data and lots of other things. Sometimes we require data we don't have, so then you can generate those data, right? For gaming you create new character. For e-commerce, create the auto generated product photos, how it will look in the new brand description and so on. So yeah, of course, it has helped us to boost creativity. It saves time. You can do the personalization based on your own content, and it can generate lots of assets quickly. And of course, anyone can access it. So one thing that is very important behind these Gen AI stuff is large language models. You would have heard of. What is large language model? Program that can understand and generate human language. So it's like uh, I'll not. Okay, let's quickly go to the next slide to understand it. What makes a language model large? So it's a large language model. Basically, it is trained using languages, the words, and it is called large because it is trained on billions of words from books, websites, articles. That's why it's able to give us. So ChatGPT, behind the ChatGPT, what is there? Data and the algorithm. So data is what large data, which is coming from websites, books, articles, and the algorithm model is transformer based architecture. So it has lots of parameters and it requires very much powerful GPUs and time to train, and only that's why big companies like Microsoft and all can afford. Google can afford to train such models, and they provide us APIs. Okay, so what they can do is they can write, summarize, translate, and do reasoning part. These are some of the famous LLM that we must have. So now ChatGPT that we are using, actually the GPT-4 model is being used here. Then these are again different models. So there's a Llama, there's a Gemini from Google, Llama from Meta. This is a free one. If anyone, if one cannot afford to pay for OpenAI, they can go with this Llama from Facebook, the Meta. They are open source, but you need to install, and that takes time. And you need to have your own GPU in that case, because when we use OpenAI, OpenAI models, the request that we pass is processing on their cloud, on their GPU, and we just get the result. when you install any model on your own system, it will be installed, but then it will be slow because if you will not have enough power of GPU. So that's important. So these are some of the models. So quickly, let's go through the capabilities and real-world application for LLMs. It can generate text, so it is used in content creation and blogs and media. It can summarize, so it is used in for executive summaries, business, legal. It is used for conversational AI. We have seen chatbot everywhere now. AI-based chatbot. It can generate code, so coding helps in software development. It can translate now. Translation between the language has become very easy because of AI. It has reasoning. You ask. You can even ask mathematical question and it can give you. It cracks that. So for education, tutoring, Q&A platform, real world use cases, it has become very handy. You can retrieve information. You can do literature reviews, research, which used to take days in past. It now only takes minutes. That's huge. You can draft a document, has for HR automation, legal drafting. It can interpret data. You just put the graph and it will explain. It will create business report. It will give you analytic explanation and will save lots of time. And just personalization, marketing, recommendation, and so on. Lots of application. And then prompt engineering, something it's nothing but when, for example, chat GPT is there, we ask, but then what when we ask, that's nothing but prompt. So prompt engineering is the practice of crafting clear and effective instruction, so to get the best possible response from AI models like ChatGPT, Daily. Because just for example, there's a knowledgeable person in front of us. He knows everything, but if we are not able to ask properly, he won't be able to give us answer properly. So it's a basically art of asking in a good and clear way. That's called prompt, and it has started new domain itself, which is called prompt engineering. So I'll just give some prompt engineering tips. For example, one of the thing is, uh, one can also pursue this now that there is a good field here. But till how much time it will be there, I don't know. But yeah, as of now, there's quite good demand for prompt engineer also. So be specific, like whatever you want to ask, be clear. Don't just keep on adding here and there thing. Give role, like act like a history teacher, act like a doctor, and so, and then ask. And you can also ask for format, like give me bullet point answer and so on. And context, if you're giving some context, it becomes easy for AI models to give you better answer. So I think we only have one or two slides. I think we'll be done with that. So application, when it comes to application, I think throughout the slides we have already covered lots of application, data science to Gen AI. So data science is used in healthcare, finance, retail, manufacturing, like everywhere. When there is a demand for prediction, decision making, it can be any domain. And GNA application we just saw about in our slide, from marketing to creating summaries for entertainment, education, so on, and for customer support. The last thing that I want to cover for today's session is why choose a career in data science. Of course, because of its high demand, and because data is everywhere. Hmm? Every company has data, and they want to leverage the data. They want to come up with some insights, some decision using that data, because they know the data is new power. So that's why it's there, and it is used in every domain, almost from healthcare and finance to e-commerce, everywhere. And there are many, of course, when it comes to salaries, very lucrative salaries and competitive salaries there. And of course, when it comes to growth, there is lots of demand and lots of scope in the growth prospects. And main thing is it's evolving every day. And so when something is evolving, then definitely there is lots of scope there, and always something new to learn from ML to Gen AI. So I think these are enough things to convince one to pursue the career in data science. So there are different roles one can once if one is deciding to go into this part, then there are different roles, like from data analyst to prompt engineer. They have their different role, different tasks. One can be data analyst or data scientist, ML engineer, data engineer, business analyst, AI researcher. prompt engineer. So, uh, as the name suggests, their respective tasks, what they do, you can read that. And you need to understand, this is, I think we already covered, like programming language, tools, concepts, soft skills. And the final slide of today's session is this: how to get started. So now you are convinced, you have interest in this, you want to go with it. So now what to do next? So first of all, we need to, like, it's not like someone has not got 100 out of 100 in maths, then they won't be able to, it's not like, just learn the basic of statistics and how to handle data. Learn Python programming language and start. The main part here is to build something. Start from small projects, take some real world use cases, or the best way to start is, participate in competitions. And Kaggle, as I mentioned, it hosts competition. There are other websites also. So once you dirty your hand with the competitions and the real world projects, you get to learn a lot, and that's a key part. And I'll strongly recommend to participate in competitions, and it will help to enhance your skills side by side. And then there are lots of online certification available, lots of courses available, free or paid, depending upon what you want. You can, there are lots of free certification, also paid one. But do the courses, online courses available on Coursera or wherever you find it better. It is very important, it increases your credibility, right? So do projects, build your portfolio. So in your portfolio, you can show that you have done these projects, you have done these certifications, which really matters in your resume. And then you do, if you get a chance to do some internship, some freelancing, keep do that, because as much as expense you gain, it helps your build your portfolio and make it strong. So internship, freelancing, it will again add up to your experience and your skills in the domain. And then try to expand your networks, join communities, and attend meetups and or webinars relevant to the industry, relevant to the field. And with the like-minded people, we learn a lot. And every day we learn a lot. So that's why connect with those type of people, those type of communities, and increase your networking in the same line. It will help us a lot. So this is how we can one can get started with this domain. So now let me know. I know I didn't give enough chance to ask questions, but I think I'm done. If anyone has any questions, feel free to ask.
Yeah. Thank you, Samreen. That was very insightful sessions. So if anyone has a question, you can drop your question in the chat box and Samreen will answer that. Yes, we will post the recording on our YouTube. So we can wait for that. Abdullah. Anyone has any questions? Okay, so Irfan is asking which is good course online on AI. And
Mm,
okay,
which
so
question?
yeah, so Irfan is asking which is good course online on AI. Like if do you
I cannot,
recommend
actually
any?
there are many, so I cannot recommend anything. But then there is a course available on Coursera. There are other deep learn. It depends upon what you want to learn actually. Uh, so suggest that start with the free courses first. And once you, that will help you to understand whether you really like that stuff, or you are really interested in that. So start with the free courses, whatever available. And if that grasp your interest, and you want to learn more, and the free version is not or free course is not available anymore, then definitely now it's time to take the paid one. So start with the free one and see how good you are, or how interested you are in that.
Okay, so the next question is from Ayan Khan. How fruitful is it for the diploma students since last year?
See, whether you are diploma student or engineering student or 12th pass, if you are interested, genuinely interested, and you want to help industry, or you want, or you, it's not like you are, if it's mandatory to be good in maths, not like that. But if you are interested in solving AI based problem, then anyone can pursue. It's not much about your academics actually. It's more about how personally you are exploring this thing. The important part is to build your portfolio, do as much as project possible, uh, whether you're first year student or last year student. Take out time separately out of your academics portion, and do explore what the world is trying to solve. The real world, take any real world problem and start solving. Create your own project, keep it public so that the companies and other people can take benefit. And again, if people will benefit, companies will reach out to you. So the better you can create and help community, better it will help you.
Yeah, okay, so next question is how to get the job as a fresher, because it is very difficult to get the job as a fresher in the data science.
Again, yeah, of course it is very nowadays it is of course companies they want experienced one, but then how the fresher will get job. So that's why building your portfolio matters. So it's not like the companies will check your marks or your percentage, what you achieve. They are more interested in knowing how practically you can create something. That's why it is very important to, as a fresher, do as much as project possible, push them to get, make it public, and show your employer that okay, you have just see this project, this repository that I created, so many people have benefited, so many people have liked. So they will see that. And then suppose you participated in some competition, even if you came, like your rank came as say 10th and 12th or 20, and there were say 500 participants, and you came like in first 50, that also helps building credibility. Okay, definitely you know something very powerful, that's why you crack this competition. And if you come in top 3, then there is like, that's something, no one can deny your skills then. So if you can participate in competition and can come up with a good ranking, you create some repository, some project which you make public, and people start liking. And if you push that into the git and people start giving more stars, and people start using it, then you can add these things to your portfolio, and that helps in making the credibility part. So it's not only about, you have done hundreds of certification but you have not done even single project. So employer will not choose you. So employer will choose the one who has built something and people have used it, who has participated in some competition, and have cracked that competition. So that will give more credibility to that person, instead of one who got 95 out of 100, or has have done 5 certification. So certification is also important, but if that comes with these two, that helps a lot, and it becomes very easy for employer also to choose that candidate.
Yeah, thank you. That was very insightful answer. Like, so someone is asking for ma'am's number in case of future. So I recommend if you can share your LinkedIn ID rather than sharing the number. You
Yeah,
know, if
I
if
can
anyone
share my
wants to connect to you and ask doubt about data science or anything,
Mhm.
so they can connect you on your LinkedIn.
Yeah, I can share my LinkedIn profile. Yeah.
Yes.
And I think someone asked if someone is not much into coding, can he still go into this? Will definitely can. So, see, coding is something. It will only nowadays. Coding is something. Even you just need to write a law. You just say the chatbot, okay, write a logic for this part. The code will be there. So eventually, coders' job will also go. So the future is coming where the coding will only be done by AI. So now it's more about your creative skills, how creative you are, how like how you see the data, which again AI cannot see still. So coding is very small part. Definitely you should know coding, but then learning coding is hardly a matter of few days, 3 4 days or 1 week if you want to be good. Not much more than that. And then once you know the basic in 2 days, just use the AI and that will write code for you. You don't need to be smart coder or very very experienced developer nowadays to get started with. So AI, there's a co-pilot. They just say chat GPT, to write code, just say in your simple language, in your English language, say them to write a code in say 10 different programming language, it will write for you. So that's not nowadays much important, but how you approach the problem, your creative skills matters. That is very important. How you understand business, how you understand problem, these skills are going to be very effective in future.
Okay. So one last question, and then we will wrap up. Where can you take part in competition? By us.
So I mentioned one platform, Kaggle. Start with the Kaggle. So it has lots of competition which are already completed. Some competition will always be ongoing. Just go to the Kaggle website and see. And there are lots of competition for just for learning thing. And there is a competition for which will pay you if you win. So start with Kaggle, and then eventually you will find other platform too.
Okay. So one last we can also take, where and how can I start with AI and ML?
So nowadays, because the advancement of this and the hype of around the same, there are lots of information, on the YouTube, Google. There are lots of courses available. So I'll say that it depends upon what. Just type in the Google, because I cannot recommend any single thing uh, that just do this. But one thing is clear, that when you take participate in any competition, you start knowing what you want to. For example, learning something. For example, I want to learn say ABC. I know that I want to learn ABC, so I can Google. But if I don't know that need to learn ABC, how will I even Google that? No. So when you take participation to certain competition, what happens that you understand, okay, you need to know this also, you need to know this, okay, this is something also there. So once you know, okay, this is something which also exists, you can Google, you can just go. There's not a single site that will tell you everything or will teach you everything. But now you, since you are clear that you need to learn this, you will go through five websites, five YouTube videos, five courses, and eventually you will learn it, because something you get from here, something you get from there, and it's a mix of everything. But you need to know what you need to learn. So that's why competition comes into picture. There are community, there are people with you who are participating, they chat, they share their insights and so on. That helps us understand, okay, we need to learn this too. That's how. So connect with the community.
Yeah. Okay. So thank you, Samreen, for your answering the doubts of our participants. I think we can wrap up our session. So again, thank you, Ms. Samreen Khan, for such an insightful session. You just touched each and every topic which is a part of data science, AI, ML, I mean deep learning and everything, which is itself a standalone topics which for a session. So yeah, that is very commendable for you. And so now I would like to thank PSF for organizing this session, and for all the participants to joining us and making it very interactive by asking important questions, and Naveed sir for giving me the opportunity to host this session. Also Ariba and Ashraf Khan and Nilofar ma'am to uh, for the smooth ongoing of the session. And yeah, so also we can when you for the participants, when you leave the meeting, there will be a feedback form which will be opened, so please make sure to fill that. It will help us to come up with the to improve our sessions, or we will love to hear your feedback, what do you think about our session. And also do consider joining PSF. If you will fill up or anything you want to contribute in any way you can. So I'll be dropping the contact information in case you are interested in joining the PSF. So you can contact Naveed Bhai and Nusrat ma'am. So yeah, that's all for today. I think we can end the session.